Okay, friends, today we are going to continue our discussion of the unit circle. And from class, you should have learned how to complete this unit circle from memory. And I know it seems like a lot, but if you follow the patterns, it's really not that bad. You should be able to come up with the angle measure and the radian measure and the cosine and sine, or the coordinates of each point, all the way around. And if you had to, fill out this unit circle if you were just given a blank one. And also, you should be able to, since you know at each point the cosine and the sine of each value, you should be able to take those two values and transform those into the remaining four values, the tangent, the secant, the cosecant, and the cotangent. And we have talked about that at length in class. Today we're going to add on a little bit to that. Before we get too far into this, every point around the circle has two names, and it's a degree name and a radian name. From here on out, our textbook, if we're talking about circular versus trig or trigonometric, circular means we're in radians, and trigonometric means we are in degrees. That's just our book's terminology. And when we start using our calculator for a lot of this stuff, you need to watch your mode. Okay, if I'm in, and this is my mode menu right here. If I'm in radians, my calculator is probably defaulted to radians unless you've changed it to degrees. Let's just use pi over 6 for example. If I say what is the sine of pi over 6, it's going to give me 0.5, which we can see from our unit circle right here. The sine of pi over 6 is 0.5, so that works. If I try to do the same thing and say, well, what is the sine of 45? Okay, I'm expecting to get square root of 2 over 2, and I get 0.8509, which we can double check is not the square root of 2 over 2. So what went wrong? I was looking for this number right here, the sine of 45. The problem was my calculator is in radians. So the number that I found right there is the sine of 45 radians. And where in the heck is 45 radians? Well, if you go all the way around the outside edge of this circle, you've gone 2 pi radians, and 2 pi is about 6.3-ish, to be a little bit more precise. 3.14, well, when I do that right here, 2 pi is that many radians. So if you go all the way around, you've gone 6.283. When I did the sine of 45, that would be, going around the circle 6.28 at a time, and wherever I would be when I got to 45. So 45 divided by, well, we'll just leave it at that. 45 is some amount of radians that's several times around the full circle. So all of that's to just illustrate. Watch your mode on your calculator. If I want to know what the sine of 45 degrees is, I need to change my calculator to degrees and then type sine of 45, and I'll get a very different result than I got the last time. That's the square root of 2 over 2 that I was looking for. Okay, so that's just a little general calc radian degree info. Let's talk about inverse trig functions. I'm going to keep this same page going. Here's an example of the kind of question you will get right now. Let's go with cosine to the negative 1, 1/2. So first thing you need to know about an inverse trig function. This is not, I repeat, this is not 1 over cosine of 1/2. Okay, that's not what that negative 1 means in this case. When we did inverse functions, f and f inverse, and we switched x and y and all that, that was not 1 over in that case either. Okay, this inverse represents asking the question backwards. Okay, what this question, just make sure you realize that is, I shouldn't cross out the not, that's a double negative, but you get what I mean. So what does this mean if it doesn't mean 1 over cosine of 1/2? What this means is, tell me what angle, and since I've said theta equals instead of x equals, I'm asking you for an angle, not a radian measure. Tell me what angle has a cosine of 1/2. Okay, not so bad. For right now, we're going to talk later about how there are infinitely many angles that have a cosine of 1/2, and how if you go around the circle one more time, you just keep finding another one. We kind of already talked about how there's a lot of different names for each of these spots. But for now, we'll just do whichever ones you can see right on the unit circle that we've got in front of us. So where do you see a cosine of 1/2? Where do you see an x value of 1/2? Well, here's one down here, and here's one up here. There's no other place where our x value is 1/2. And we could actually throw a little line in there to show, x being 1/2 literally means we are 1/2 unit to the right of the origin. All right, here's 0, here's 1, here's 1/2. And the two nice, neat unit circle spots that make that happen are 60 degrees and 300 degrees. So my answer to this question is 60 degrees, 300 degrees. And again, there are infinitely many answers, such as 660 degrees or negative 60 degrees. Any multiple times around the circle and stopping at this point would work, but right now we're just going with the ones that are shown on the unit circle that we can see right in front of us. Okay, so another example. X equals inverse sine of 1. So what this is saying is, you tell me, I've been asking you questions like, what's the sine of 4 pi over 3? Or what's the cosine of 5 pi over 6? In this case, I'm saying, what arc or what radian measure has a sine of 1? So sine is my y value. I need to find the spot or spots on the unit circle that have a y value of 1. And for us, that's this one place right up here. That's the only place where this circle reaches a height of 1. All right, one important fact you should never forget about sine and cosine: they always live between -1 and 1. All right, because this unit circle never goes any further left or right or up or down. So my one answer to this question, where is sine equal to 1, is pi over 2. All right, and ask yourself this question: why did I say pi over 2 instead of 90 degrees? If you're not sure, you can ask me in class. So there is our first little crash course on inverse trig. It's just asking the question backwards. Instead of me saying, what's sine of pi over 6, and you say 1/2, I say, what angle has a sine of 1/2, and you say pi over 6, or 30 degrees. All right, so there's our little bit about inverse. Now let's talk about approximate values. This is going to be the easiest thing we've done in a while. All those nice little unit circle values are the ones that we memorize. Because they have exact answers, like square root of 3 over 2, and square root of 2 over 2, and 1/2, and all that. And, if you're in any real-world situation, you're probably going to have to find sine or cosine or tangent or any of the others for an angle that's not one of those nice, unique places. So how do you do that? Well, piece of cake. You go to your calculator and you type it in. For example, what is the cosine of 78 degrees? Well, it's not one of my unit circle spots. So if my calc's in the right mode, I'm in degrees here, so check my mode. Yes, I'm in degrees. So all I have to do is type in cosine 78. Easiest thing we've done in a while. And let's call it 0.2079. All right, no big deal. The reason it's called an approximate value is because my calculator is giving me a rounded off value for what is the cosine of 78. That 908 at the end is rounded off, and this decimal would keep on going if I had a calculator screen big enough. So let's just refer back to our picture one more time to see the cosine of 78 is about 0.2. So where is 78? Let's actually get a new picture. We'll go with degrees. cosine of 78 is what I just found. 78 degrees, here's 90, 60, halfway between there, you know, we're about right here. Let's call that 78 degrees. Well, what's the cosine? Well, cosine is always x. So if I were to make a little right triangle, here's that 0.2 right there. And it makes sense. If this is 1, then 0.2 goes out about that far. While we're on the topic, what's the sine of 78 degrees? And you should have in mind a number. It looks pretty darn close to 1, because when I get to the very tip top of the circle, my sine value, which is over here on this side, is pretty close to 1. So let's try sine of 78 and see what we get. 0.978. So 9781, let's say, which is pretty close to 1. So there you go. What if we're trying to do our inverse on the calculator? All right, we learned how to do sine and cosine and tangent and etc. in class. We did the inverses just a minute ago on our unit circle spots. But what about a question like this? Theta equals cosine inverse of 0.9125. So what is this asking us? This is not saying 1 over the cosine of 0.9125. This is saying, where is the cosine equal to 0.9125? And if it's not a unit circle spot, that's just as easy as hitting second cosine 0.9125. And what the calculator is going to tell us is what angle do I need to go to for my cosine to be 0.9125, and that's 24.14 degrees. Let's call that 0.15 degrees. So what does that mean? That means if I go to 24 degrees, which is about right here, that my cosine, or my x value, which is this part of the triangle, you can see it's almost to the edge, so it's almost 1, and it's 0.9125. So inverse trig on the calculator is a piece of cake. You just hit the second button first before you hit your sine, cosine, or tangent. Okay, one more thing. On your calculator, if you get a question like this, tangent of, let's say, 5.3. Now that's 5.3 radians because there's no degree symbol. So I want to find the tangent of 5.3 radians. First of all, my mode needs to be in radians. And actually, I didn't mean to do tangent. Let's do cotangent, because there is a tangent button. I'm trying to show you what to do if there's no button. Cotangent of 5.3. There is no cotangent button on this calculator. All right? It is not going to be tangent inverse. .3. That's not the same thing. It's not 1 over. Cotangent of 5.3 does equal 1 over tangent 5.3. Not inverse tan 5.3, but 1 over tan of 5.3. All right, we learned those rules about tangent and cotangent earlier. So there's no cotangent button, but all that means I need to do is say 1 divided by the tangent of 5.3. My answer is negative 0.666101193. So let's see, negative point. I'm going to call that negative 0.67. So think about what we've found, the cotangent of 5.3. So wherever 5.3 radians is, which is almost all the way around the circle, the cotangent of that value is negative 0.67. And here's the last thing. What about something like this? Secant inverse of 3.7. What this means is this is one of the three that's not on your screen, not on your calculator, and you want to do the inverse of it. So what it seems like maybe you should do is this: 1 over cosine inverse 3.7. It's a very common misconception, but that's the wrong order. The right order is this. You need to put the 1 over 3.7 and then cosine inverse of that. And I'm 13 seconds from running over my YouTube limit. So write that down. We'll talk about it more in class. Young, and I'm out.